Hello dear students of the third prep grade, and welcome to a new episode of our program. It's time for mathematics, and on this episode we'll be studying lesson 2 of unit 4. We'll be having some applications on trigonometry with our teacher of mathematics, Mr. Ashraf Helmi, expert of mathematics at the Ministry of Education. Hello Mr. Ashraf, and welcome to the program.
Hello, how do you do?
I'm fine, thanks. How about you?
Thank you.
All right, Mr. Ashraf, let us in brief know what are we gonna have in this lesson.
Inshallah, in this lesson we're gonna study some applications in trigonometry, and we're gonna solve some examples on the pupil book. Actually, it's very important to solve examples in the pupil book because it's the main source for students to study, which the exercises in the pupil book should be done by all students.
So if you're going to have applications on trigonometry, so what should the students already know before starting these applications?
Applications in trigonometry, so we have maybe to revise on what do you mean by the sine of the angle, the cosine and the tan for the angle. Let's revise on this and do some applications on the pupil book.
Yeah.
So first, let's have a right angle triangle, because this is the main shape that we are going to study. We have a triangle, right angle triangle ABC. It's a right angle triangle at B. So if I want to find the sine of angle C, so sine angle C, as the rule of the sine, is the opposite over the hypotenuse. So this is angle C, and the opposite side of angle C, it's line segment AB. So we have AB over the hypotenuse, which is AC. The ratio between these two, the length of these two sides, is the sine of angle C. And we knew before that cosine angle C, and the rule of the cosine for any angle, it's the ratio between the adjacent and the hypotenuse of this angle. So I have to write as cosine angle C, it's BC over the hypotenuse, which is AC. And finally, the tan of the angle C, so tan C equals, and for tan C, it's the ratio between the opposite of angle C and the adjacent of angle C. So we have here the length of AB over the length of BC. This is what we have revised on trigonometry before going on the applications on the pupil book.
All right, so now we're going to start having some applications. So could you tell us the page number?
So we have the pupil book, and actually it's page 61, and it's page 61, exercise 4.2. And exercise 4.2 is abbreviation for unit 4, as you said before, and lesson 2.
Mm-hmm. All right, so everybody, if you've got the book, please open your books at page 61. All right.
Okay, let's start with exercise number 5. It's connecting with geometry, and the exercise says that if we have a rectangle ABCD, so let's draw the rectangle. This is rectangle, and this is A, B, C, and D. And it's written in the pupil book, ABCD is a rectangle in which AB equals 15 centimeters, and this is AB 15. And as long as AB is 15 centimeters, of course, DC, which will be 15 centimeters. And we have AC, which is 25 centimeters. This is the diagonal of the rectangle, which is 25. And the first thing I have to know here, how can I find measure angle ACB? So this is the first required in the question. First, measure angle ACB. Okay. The first thing we have to do in something like this, we have to identify measure angle ACB. Where is angle ACB? Actually, the vertex is C, so angle ACB, this is angle ACB. And as you see, in angle ACB, this opposite side of this angle is AB, which is 15 centimeters, and the hypotenuse of this angle is AC, which is 25 centimeters. And usually, when you were in fourth or maybe fifth primary, use the protractor to find the measure of this angle. But now in trigonometry, we are going to use the trigonometrical ratios to find the measure of angle ACB. And to do so, we have to check which one of the ratios should I work on. As we said before, in this triangle, we have the opposite of this angle and the hypotenuse. And as long as we have the length of these two sides, we have to use the sine rule to find the measure of this angle. So all what you have to do is to write the rule of the sine for this angle. So I'm going to write here sine angle ACB equals the length of the opposite side of this angle, which is 15, over the length of the hypotenuse, which is 25. Okay, now I have to use my scientific calculator to find the measure of angle ACB. So when I want to find the measure of angle ACB, I have a new abbreviation from the sine. Or what I'm going to write is the inverse of the sine function, as it's written like this, for 15 over 25. And this abbreviation, again, I'm going to say, what do I mean by this abbreviation? It's abbreviation to find the inverse of the trigonometrical ratios. So I can find the measure of the angle, which its sine gives me 15 over 25. I'm going to say this again. This abbreviation helps me to find the measure of the angle whose its sine 15 over 25. Actually, this abbreviation for the cosine and for the tan also. So all what you have to do is to use your calculator and press shift sine. It's abbreviation for the inverse of sine, and you have to write the fraction 15 over 25. So I'm going to use my calculator, 15 over 25, and find the answer. Actually, the answer, when you got the answer in your calculator, the answer, it will be written in decimals. So you have to convert this decimals into degrees, minutes, and seconds. So the measure of this angle, when you want to convert it to degrees, minutes, and seconds, you have to press on the bottom that change this angle to degrees, minutes, and seconds. So I'm going to write this again, the inverse of sine, which is shift sine in your calculator, and I'm going to write 15 over 25. And when you press on equals to find the answer, you have to press on the bottom that change this to degrees, minutes, and seconds. And the answer, actually, in your calculator, it will be 36 degrees, 52 minutes, 11.63 seconds. This is the measure of the angle whose its sine gives me 15 over 25. And we knew a new abbreviation for the inverse of sine, which is sine. Actually see a small prefix or index on this sign, which is -1 here. So we can find the measure of the angle. The second required in the question, which is, we have another required in the question. We are in page 61, as we said before. And the second required, would you mind read the second required,
yeah,
please?
it asks for the surface area of the rectangle A, B, C, and D.
Thank you. So the surface area of this rectangle, of course, we have to find the length and the width of the rectangle. So when we want to find the length of the width and of the rectangle, as you see in the shape again, I have the width of the rectangle, which is 15 centimeters. So I have to find the length of the rectangle, which is BC. And of course, usually I can find BC using Pythagoras rule, because we have here an right angle triangle. So I can find the length of BC using Pythagoras rule. So the BC equals, so BC equals the square root of 25 power 2, which is the hypotenuse to the power of 2, minus minus the length of the other side, which is 15 power 2. And usually when I want to use something like this, use your calculator. So I'm going to write here square root on my calculator, and I'm going to write 25 to the power of 2 minus 15 to the power of 2, and the answer, it will be 20 centimeters. So BC is 20 centimeters. So I wrote here, I'm going to write here 20. So the area of this rectangle is the length times width, so 15 times 20. So I can find the area of the rectangle. So area equals 15 times 20, and the answer is 300 centimeters squared. So this is our exercise, which is exercise 4, maybe you said before?
Yeah, it's a 5. It's actually
Exercise
exercise 5.
Okay.
Yeah, page 61. Remember, this is a page we're working on at the moment. We have also number 6, Mr. Ashraf. It says in the figure, the opposite figure, there is A, B, C, D.
Yes, it's a parallelogram. Yes,
yeah,
it's a very important
parallelogram
shape.
of
Yes.
surface area 96 centimeters, power 2, BE to EC equals 1 to 3.
Okay,
right.
I'm going to draw this for
Yeah.
my students. So this is our parallelogram, which is drawn in your book. So this is A.
And this
B.
parallelogram is found in the book, right?
Yes, it's drawn
Yeah.
in their books. So this parallelogram has area which is 96 centimeters squared. I'm going to write here 96 centimeters squared. And let's remember how can I find the area of the parallelogram? Actually, the area of the parallelogram equals the length of the base times the length of the height of the parallelogram. And the height of the parallelogram is drawn in the shape. This is the height, and it's the length of this height is 8 centimeters. This is 8 centimeters. So as long as I have the area, which is 96, equals the length of the base times the length of the height, which is 8. So if I want to find the base, so I'm going to divide 96 divided by 8. So the base, or the length of the base, I'm going to divide 96 divided by 8. The answer is 12 centimeters. So this is our first step. So what I did is I found the base, or the length of the base of the parallelogram. All that I did, I divide 96 by the length of the height, and the answer is 12 centimeters. The second step in the question is written here. BE, the ratio between the length of BE to the length of EC is 1 to 3. So I'm going to put these ratios on the drawing. So I have here the length of BE. This is 1, and this is 3. Actually, this is the ratio between the length of these two parts. These are not the real length of these two parts. This is the ratio between the length of these two parts. So as long as BE, the ratio between BE to EC, it's 1 to 3. And of course, their sum is 12. I'm sorry, it's 4. And the real length, or the sum of the real length, is 12 centimeters. And to find the length of EC and BE, so of course EC, its length, it will be 9 centimeters, and BE, its length, it will be 3 centimeters.
We have 3 requirements here.
Yes, all what I did, something about preparing my question to solve the requirement. And actually, the first requirement here is finding the length of AD, and I found the length of ED, which is the base, which is 12
Let me
centimeters.
remind them, this is page 61 of your student's book.
Yes. So the first required here, first find the length of the line segment AD, and as long as the base is 12 centimeters, I found that this is the length of BD. BD is the base of this parallelogram. So I have finished the first required. The second required is, how can I find the measure of angle B? And as you see, we have a right angle triangle here, which is AEB. This is a right angle triangle. And to find the measure of this angle, the usual way is to use the protractor to find the measure of angles. But actually, we work on trigonometry, so we passed this level. And we are going to use trigonometry to find the measure of this angle. And we are going to use the sine, cosine, maybe a tan to find the measure of this angle. So let's check what are the length of sides do we have in this triangle. And we have here the opposite of this side. And BE, actually, we found the length of BE, which is 3 centimeters. So the length of BE here, I'm going to write this, it's 3. So in this triangle, I have BE, which is 3 centimeters, which is the adjacent of this angle. And I have the opposite of this angle, which is 8 centimeters. And the trigonometrical ratios that I'm going to use here, which is the tan, because tan of the angle is the ratio between the length of the opposite and the adjacent. So I'm going to write here in this part, the tan, or the tangent of this angle, angle B, equals the opposite, which is 8, over the adjacent, which is 3. So measure angle B equals, I'm going to find the inverse of tan for angle B. I'm going to search on my calculator by pressing inverse of tan for 8 over 3. So measure angle B equals. Measure angle B, I'm going to use my calculator now. Let's work on the calculator. Or what you have to do when you have your scientific calculator is press shift and press the bottom tan on your calculator to find the inverse of tan for this angle. And when you press on the inverse of tan, you have to write the fraction that we have here, which is 8 over 3. So I'm going to write 8 over 3 and press equals. And of course, the angle here, it will be in decimals, and we don't work on decimals for the angles. So I'm going to press again on the bottom that convert the decimals to degrees, minutes, and seconds. And the answer, it will be 96 degrees, 26 minutes. So I'm going to write here, measure angle B, which is the inverse of tan, for 8 over 3. I'm going to search now on my calculator by which angle, what's the measure of the angle that its tan is 8 over 3, and measure of this angle, it will be 69 degrees, 26 minutes, 38.24 seconds. So this is measure angle B. And for the third required, would you mind read the third required?
Yeah, it says, or it asks for the length of AB,
yes.
Line segment,
yes,
to the nearest decimal number. And it says here something really interesting. It says use more than one way.
Okay, thank you for this. Actually, we have two ways to solve this thing. We can use a third prep way or a second prep way.
Yeah. But can this be asked in the exam?
Of course not.
Yeah.
Of course not. We have
just one way.
We have, yes.
And they have the freedom to choose whatever way they want to.
You know, some kinds of questions, some students surprise you about the ways that they solve.
Yeah.
So we have to look for what kind of minds for students. So maybe they can use a simple way, and some of them maybe use a hard way to solve an example.
Yeah, but all roads lead to Rome.
Yes, lead to Mecca. So we have here a right angle triangle. I'm going to draw a right angle triangle here. And this right angle triangle is, you know, I'm going to draw a part of the parallelogram. I'm going to draw the left part of the parallelogram, which is triangle AAB. And we knew that this is 8 centimeters. I make a snapshot for the drawing. I didn't draw all the parallelogram. I have a snapshot here for the drawing. It's a part of the right angle triangle. And BE here, it was 3 centimeters. So it asked me to find the length of AB. And so the simplest way is using the Pythagoras rule. And to find the length of AB using Pythagoras rule, it's a second prep level. So AB equals square root 8 power 2 plus 3 power 2, which is square root 64 plus 9, which is square root 73 centimeter. And this is the question asked me to find the length of this part to the nearest centimeter. So I have to use my calculator to find root 73 on the calculator. I'm going to draw right here root 73 and press equals. And the answer here, it's
remember, they can't see the laptop.
I know they can't see the laptop, but it's a calculator. It's simply used. They can use calculators to find square root 73 and convert it to decimals. It's not a hard way. So the answer here equals 8.544. But the question asked me to find this length to the nearest a decimal number, one decimal number. So the answer approximately it will be 8.5. And this is the length of AB in this way, which is the simplest way to find the length of AB. But there is another way to find the length of AB using a third prep rule. We have here...
Which is easier, the one you did or the one you're going to do?
The one I did, actually. It's the more easier than what I'm going to do now. This is 8 centimeters and this is 3 centimeters. We got before the measure of angle B. And for the measure of angle B, I'm going to put this here, the measure of angle B, we got the measure of this angle. And the measure of this angle, we got it as 69 degrees, 26 minutes, 38.24 seconds. Now, I want to find the length of this hypotenuse. I have here the length of the adjacent of this angle and the length of the opposite of this angle. So maybe I can, to find the hypotenuse, I use cosine or sine to find the measure of angle B. If I want to find the sine of this angle, I know that sine angle B equals the opposite, which is AE, over the hypotenuse, which is AB. Okay, let's replace the letters by the numbers. Sine B, which is sine 69 degrees, 26 minutes, 38.24 seconds, equals the length of AE, which is 8, over the length of AB, which is, I want to find, this is AB. And using simple cross multiplication strategy, I'm going to find AB and AB here. It will be approximately 8.5 centimeters. Maybe I can use another way to find the length of AB by using the cosine rule.
Yeah.
So we have finished this exercise.
All right, now let us move to the next. Let me remind you, everybody, we're still on page 61. We're having some applications on trigonometry. Let us move now to number 7.
Okay.
Number 7 in your book, page 61, and it says in the figure opposite ABCD is an
isosceles.
What do you call it?
Isosceles trapezoid.
Isosceles, yeah.
Isosceles
Trapezoid in
trapezoid.
which, yeah, AB equals AD equals DC equals 5 centimeters and BC equals 11 centimeters. So the first requirement says measure angle B, measure angle of B, and measure of angle A.
Okay, I'm going to draw this trapezoid on the screen here. So this is 11 centimeters. We did something like this before in the last episode, and actually the required here changed, and or maybe we have a new required here in the question, which is the first required, measure angle B and measure angle A. So we don't have here in this drawing a right angle triangle, so we have to make a construction. We have construct like an engineer. A construction to form a right angle triangle here. And the first part we say before, to construct a right angle triangle here, I'm going to draw a perpendicular line from A, like this, and I'm going to name this vertex. What's your name? Okay, what's your name?
Yes.
Yes, sir. So I'm going to name his Y. Okay. So and we have another construction here. I'm going to draw a line here, a perpendicular line here in this part, and I'm going to name this point, for example, X. So now this shape is a rectangle, so this is 5 centimeters, so actually X, the length of XY, it will be another 5 centimeters. And actually these two triangles are congruent triangles, so this 11, when I subtract 5 from 11, so the left we have 6, and this 6 is divided between the length of these two sides, CX and BY. So this, it will be 3, and this is 3. Okay, here's of course 5, it's written in the question. This is 5 centimeters, and this is 5 centimeters. Now, the first required way I have here is finding measure angle B. So if I want to find measure angle B, and in this shape, all what we have is the length of the adjacent of angle B, which is BY, and the length of the hypotenuse, which is AB. So the main trigonometrical ratios that use the length of the adjacent and the length of the hypotenuse is the cosine. So I'm going to write here that cosine angle B equals the length of the adjacent, which is 3, over the length of the hypotenuse, which is 5. Again, we are gonna use our calculator to find the angle, which is its cosine is 3/5. So I'm gonna write the inverse of cosine for 3/5 gives me the measure, I'm gonna write this, the measure of angle B. So using my calculator, simply use your calculator, and the first step, all what you have to do to press shift on your calculator and press on the button of cosine. And when you press shift on the button of cosine, it will be written in your calculator as the inverse of cosine. And you have to write the fraction, which is 3/5. You have to use the fraction way, which is 3/5. Of course, you have to bring your scientific calculator when you watch this episode. Then we use the bottom of converting a decimal to degrees, and the answer it will be, measure angle B, it's 53 degrees, 7 minutes, 48.37 seconds. So I got A. I got the measure of angle B, and I got the measure of angle C because we have an isosceles trapezoid, so the measure of angle B, it's the same as measure angle C. Okay. The second required is finding measure angle A. And actually, for measuring angle A is divided into two parts. The first part is 90 degrees, as you see here. And this is the other part. Okay. The most simple way to find measure angle A is using the parallelism. As you see, we have a trapezoid, so we have two parallel lines here. And as we have two parallel lines here, so measure angle A plus measure angle B equals 180 degrees because they are interior angles. And I got B. So when I want to find A, all what I have to do is that measure angle A equals 180 degrees minus 53 degrees, 7 minutes, 48.37 seconds. And use your calculator to find the measure of this angle simply. So we have finished the first required.
Yeah, the second one, the area of the isosceles trapezoid ABCD.
Okay. For the area of any trapezoid, as we said before, simply, all what you have to do, the first way is you have to remember the rule how to find the area of a trapezoid. And the rule of finding the area of a trapezoid is the average base multiplied by the height of the trapezoid. And for the average base is the sum of the two bases divided by 2. So again, the first simple way is you have to remember the area of a trapezoid, and the area of the trapezoid is the average base, which is the sum of the two bases divided by 2. So 5 plus 11 divided by 2 multiplied by the height of the trapezoid, which is AY or DX, and its length is 4 centimeters. So the area equals 5 plus 11, which is 16, and divided by 2, the answer is 8 times 4, so the answer is 32 centimeters squared. Another way to find the area of the trapezoid is, as you see here in the drawing, we divide the trapezoid into 3 equal parts. We have 2 right-angle triangles and 1 rectangle. So you can find the area of this triangle, and doubling the area by multiplying by 2, because we have 2 right-angle triangles, plus the area of the rectangle. And of course, the answer to be the same as we did here in this part, which is 32 centimeters squared. So we have finished, I think, the applications on this page.
Yeah, and we're moving now to the next page, page 62. Page 62 of your book. And we have this exercise here about a trapezoid-shaped piece of land, ABCD, in which line segment AD is parallel to line segment BC. Measure of angle B equals 90 degrees and AD equals 20 meters. All right. And then BC equals 35 meters and DC equals 25 meters. I'm just reading out what you have in your book.
We have 3 requires actually.
We have
the most important 2 requires we are gonna answer is find the length of AB and find measure angle C.
Yeah.
So let's draw the trapezoid, and it's not isosceles trapezoid as you see, it's a right angle trapezoid. So we have here a right angle trapezoid. This is B, this is A, D, and C. And this is 25 centimeters. This is 25 meters, and this is 20 meters, and this is 35 meters. Okay. The first required is how can I find the length of AB, actually, which is the height of the trapezoid. Again, we don't have right angle triangle here. So I have to construct, make a construction to form a right angle triangle. I'm going to draw a perpendicular line from D to form a right angle triangle. I'm going to name this point as Y. As long as I did here, we have a small rectangle here, which is ABYD. And AD, it has a length 20 meters, so of course BY, it's the same, it will be 20 meters. And for BC, it's 35 meters, and this is 20 meters, of course. CY, it will be 15 meters. And for right angle triangle, DCY, to find the length of DY, so DY equals, using Pythagoras rule, Mr. Pythagoras, it's square root 25 squared minus 15 squared. And of course, dy, it will be 20 meters. So this is 20 meters, and we said before that this shape is a rectangle, so dy, it's 20, so of course AB also, it will be 20. The second required is how can I find measure angle C? And we said before, to find measure angle C, the usual way that we use a protractor, but actually this drawing, actually it's not a real drawing, of course it's not 25 meters, it's not 35 meters, it's a freehand drawing. So we don't use a protractor here, and we are in third prep, so we are going to use the trigonometrical ratios to find measure angle C. And as you see here, measure angle C, the 3 sides, which is the opposite of angle C and the adjacent and the hypotenuse for angle C, we knew the length of these 3 sides. So for any trigonometrical ratios I can use, and the simple way, maybe it's a simple way for me, I'm going to use the inverse of sine for the length of the opposite over the length of the hypotenuse, which is 20 over 25. And as we said before, use your calculator to find this measure of this angle and convert it to degrees, minutes, second. And this is what we have in this exercise. Let's move on for the unit test. We have some exercises in the unit test, which is a nice exercise. Exercise, for example.
Which page?
It's the same page.
Page same 60, page, yeah.
62.
Yeah, okay. Prove each of the following equalities.
It's exercise number 5.
5. Yeah.
Yes,
okay.
a ladder of line segment AB of length 6 meters.
Is it on the same page?
Yes, it's in the same page, page 62.
Okay.
Yes. A ladder line segment AB of length 6 meters. And its upper edge A lies on a vertical wall and its other edge B on a horizontal floor. So we have here in the drawing, I have a wall and a horizontal floor. This is a wall and this is a horizontal floor. And we have a ladder which is upper edge, A lies on the vertical wall. So this is, for example, point A. And the other edge, B, on the horizontal floor. And this is B. So this is the ladder. And of course, this is a right angle triangle. I'm going to name this point. No, I will not name it. Let's read the question. If C is the projection of point A on the surface of the floor, so C is the projection of A. And what I mean by word projection is the position that line segment drawn from A perpendicular to the floor. So this is the position of point C.
I just want to remind you that we didn't have number C, or the third requirement of the previous exercise.
Yes, yes.
Do you mean to do that?
Yes, I mean to
Yeah.
do that. It's a simple question.
Yeah.
I worked on letter A and B because the most hard question, but letter C, maybe when we finish this exercise, I can work on this.
Yeah, so you skipped it.
Yes, I skipped it. It's a simple one. It's finding the area of a circle. It's pi r squared. If you want to
No, it's okay. I mean, you know better, of course.
Okay, let's back again to exercise number 5, page 62, the unit test. So this is exercise number 5, page 62. We have here something else in the question, and which is if C, it's we said before, is the projection of point A on the surface of the floor, and its angle of slope on the surface of the floor was 60 degrees. Actually, this sentence make some students confused about what's the slope of the surface of the floor. And the slope here of actually the ladder makes angle on the floor. And the measure of this angle is 60 degrees. So let's back again to the drawing. So this is the ladder, and this is the floor. So the angle which made by the ladder on the floor is 60 degrees. So this is 60 degrees. Now I have to find the length of AC. The given here is the length of the ladder, which is 6 meters. And of course, as long as this is 60, this is 90, so measure angle A, it will be 30 degrees. And we studied before in second prep that the length of the opposite of angle 30 in a right angle triangle, its length is half the length of the hypotenuse. So BC equals 3 meters. That's all. A simple question. If you can't draw the question well, you can find the length of BC. As you see, there is no steps in this question. A simple question, 60, 30, so the length of the opposite side of 30 is half the hypotenuse. So BC is 3 meters, no problem in this exercise. We have another exercise, which is exercise number 4. And exercise number 3. Let's work on exercise number 3, because exercise number 4 is the same as we did something like this before. ABCD is a trapezoid.
Please tell us the page again.
Page 62.
62, same page.
Same page, it's a unit test. We have exercise number 3, a new shape, which is an isosceles triangle.
Are these exercises answered in the book?
Of course not. It's an exercise for
not at the back of the book as we used to have in our books.
There is some answers for exercises at the end of the books, but not all.
But not this one.
Yeah. Not all exercises we have answers.
Are answered.
Yes. For exercise number 3, page 62. This is 3, page 62. We have ABC is an isosceles triangle in which AB equals AC, so I'm going to draw an isosceles triangle. And this isosceles triangle, it has 2 equal sides in length, of course. So we have AB equals AC, so I'm going to put here is A, here is B, and here is C. And the length of these 2 sides is 12.6 centimeters, and here's another 12.6 centimeters. For measure angle C, it's 84 degrees 24 minutes. So the measure of this angle, I'm going to write it here, is 84 degrees 24 minutes. And of course, as long as this is an isosceles triangle, so measure angle C is the same as measure angle B. So measure angle B also, its measure, it will be 84 degrees 24 minutes. And if I want to find the measure of angle A, simply I'm going to find the sum of these 2 angles and make 180 minus the sum of these 2 angles to find measure angle A. The last given here, which is BC, its length is 10 centimeters, so I'm going to write here 10 centimeters for BC. Prove that here cosine angle DCB minus tan angle ACB equals 1 over 2. So the strategies that we are going to use in proving for trigonometry, we said before, we use the left-hand side, right-hand side strategy. I'm going to work on the left-hand side and simplify the left-hand side as much as I can and work on the right-hand side, simplify it as much as I can to find if the two sides are equal. And actually the right-hand side, there is no simplification for the right-hand side, which is half, so I'm going to work on the left-hand side. So we have exercise 3, page 62. ABC is an isosceles triangle, so I'm going to draw an isosceles triangle. ABC, in which AB equals AC, which is 12.6 centimeters. So of course this is A, and these are the two equal sides, and this is B, and this is C. And the length of AC is the same as the length of AB, which is 12.6, and this is 12.6 centimeters. Measure angle C. It's 84 degrees 24 minutes. So I'm going to draw here. This is angle C, and its measure is 84 degrees 24 minutes, which is the same as measure angle B, which is 84 degrees 24 minutes. And the question here says, find the length of line segment BC to the nearest decimal number. If I want to find the length of BC, I'm going to use the trigonometric ratios here. So I have to construct a line that's forming a right angle triangle. So I'm going to draw a perpendicular line from A. I'm going to name this point as Y. So this is a right angle triangle. If I can find the measure or the length of CY, of course I can find the length of BC. So my aim now, I have to find the length of CY in this right angle triangle. I have the length of the hypotenuse, I have the measure of angle C, and CY is the adjacent side of angle C. So I'm going to use the cosine rule. So cosine angle C equals CY, the length of CY over the length of AC. So I'm going to replace the letters by numbers. So cosine C, which is cosine 84 degrees 24 minutes, equals the length of CY over 12.6. So CY equals, using your calculator to find the length of CY, all what you have to do here is multiplying 12.6 by cosine 84 degrees 24 minutes. So I'm going to use my calculator. As you see here, again, I'm going to show you. For this equation, to find the length of CY, you have to multiply 12.6 multiplying by the cosine of angle 84 degrees. And we knew before, how can I write this simple on the calculator? How can I write 84 and press the bottom to draw degrees? Then 24 minutes, so you have to press on 24 and draw minutes and then find the answer. And the answer of CY here, approximately it will be 1.2 centimeters. This is the length of CY. And for the length of CY 1.2, I'm going to duplicate this length to find the length of BC. So BC equals 2 times 1.2, and the answer, it will be 2.4 centimeters. So this is the length of BC that we have here in this exercise.
All right, how about if we go back to number 1, all right?
Okay, proving.
Yeah, prove each of the following equalities. It says sine 60 degrees equals 2 sine 30 degrees cosine 30 degrees. So this is the first one.
This is the first one in unit the test, page 61. So as we said before, for any exercise in trigonometry, we use a strategy which is the left-hand side strategy and the right-hand side. So in this strategy, we work on the left-hand side, which is sine 60. We have to find the sine 60, or you can memorize sine 60, which is root 3 over 2. So this is what we have in the left-hand side. And for the right-hand side, we have 2 multiplied by sine 30 multiplied by cosine 30, which is 2 times, and sine 30, which is 1 over 2, times cosine 30, which is root 3 over 2. And of course, 2 multiplied by half, it will be 1. So the answer, it will be equals root 3 over 2. And as you see here, the left-hand side here is the same as the right-hand side here. So we proved this equality, which is sine 60 is the same as 2 sine 30 cosine 30. So we have finished this exercise. We have another exercise. What about exercise number 2? It's a new idea.
All right. Let us move to exercise 2
Yes.
of the same page. All right, 62, page 62. Without using the calculator, find the value of x, where x is an acute angle satisfies each of. Do you want number A?
Yes, okay,
all right.
let's do this
10
one.
x
10,
equals
yes,
equals 4 cosine 60 degrees sine 30 degrees.
Okay.
And perhaps this is gonna be our last exercise for this episode.
So we want to find the measure of angle x. So I'm going to work on the right-hand side here. So 4 multiplied by. And for cosine 60, you have to memorize something like this without using calculator. Cosine 60 actually is the same as sine 30, because the sum of these two angles is 90 degrees. So cosine 60, which is 1 over 2, multiplied by the sine 30, which is 1 over 2. So tan x equals the product of 4 and half and half. So the answer is 1. So the tan of the angle, which is answer is 1. Of course, this angle is 45 degrees. So x is 45 degrees, and this is what we have in this exercise. Another one, which is maybe letter B.
Yeah, let us move to B.
Yes, it's more complicated than letter A.
Yeah, it seems to be. It says 2 sine x equals 30 degrees, cosine 60 degrees, plus cosine 30 sine 60 degrees.
Okay, so this is sine 30 cosine 60 plus cosine 30 times sine 60. Okay, so we have here for the right-hand side, we have 2 sine x equals, and for sine 30, the answer is half, multiplied by. Cosine 60, the answer is another half, plus. For cosine 30, it's root 3 over 2. Multiply cosine 60, which is another root 3 over 2. So 2 sine x equals half times half. The product of these two halves is 1 over 4, plus. The product of these two numbers, root 3 over 2 times root 3 over 2, the answer is 3 over 4. And the sum of quarter and 3 quarters, so 2 sine x equals 1. When I want to find sine x, I'm going to divide the two sides of the equation by 2. So I'm going to cancel here 2 by 2, simplifying. So sine x equals 1 over 2. And as long as sine x is 1 over 2, the angle which is its sine is 1 over 2 is 30 degrees. So x here equals 30 degrees, and this is what we have in this exercise.
Can we go back to number B of the first one, or I guess no, it's time for ending this episode. So I'd like to thank you very much, Mr. Ashraf Helmi, for having you with us and for your interesting explanation of this lesson. Thank you very much.
You are welcome. Thank you.
So that brings us to the end of this episode. Dear students of the 3rd prep grade, remember we've had some applications on trigonometry during this episode. I hope it's been a useful one, and until we meet you again next week, inshallah, we wish you all the best. Goodbye.